So we ended the last lecture talking about how matter is measured. We looked at the difference between mass and weight. And so now what we're going to do is spend a little bit of time looking at the different types of matter. How do we classify matter? And this is more than just like solid, liquid, gas. This is kind of putting matter into some major, very large categories rather than looking at something specific. But first, before I get to that, I want to highlight since a good deal of this course is talking about focus, or we focus on the changes in matter. One of the laws, talked about laws earlier, that governs the changes in matter is something known as the law of conservation of matter. And this says that there is no detectable change in the total quantity of matter when matter gets converted from one type to another, either through a chemical change, or when it changes from solid to liquid to gas, a physical change. And basically what this is saying is that if matter undergoes any sort of change, however much you start with, you're going to end with that. And so that is one of the major governing laws behind matter. So the way we classify matter is it's either a pure substance, which means it is in a constant composition. And what that basically means is that all specimens of a pure substance have exactly the same makeup and properties. So for example, water, if you have pure water, nothing else in there, then it doesn't matter if you take out a little bit of that water or a lot of it, it's still going to be same. Every part of that is going to be water. Every molecule in there is going to be water. Let's take table sugar, for example, also known as sucrose. Sucrose is 42.1% carbon, 6.5% hydrogen, and 51.4% oxygen. Now, that's not something you need to memorize or know, but what I bring that up, those percentages, is that all sucrose, all table sugar has that exact composition, nothing more and nothing less. And that's what a pure substance is. A mixture is composed of two or more types of matter that can be present in varying amounts. And this is kind of another important part. So I kind of got like three main points here. It's composed of two or more types of matter, and that composition can be different amounts. And then three, they can be separated by physical means. Like for example, let's just take salt water. So let's say you take a pinch of salt and you dissolve it in water. Then you go take that water and you boil it, and then you boil it and you boil it and you heat it and you heat it. And eventually over time, all of that water has evaporated and it leaves behind the salt. It leaves it behind the solid salt. So that's how you can separate that by physical means. Now, I can make that salt water mixture more strong, so to speak, by instead of having a pinch, maybe I add like a cup of salt. And we can, physically taste that difference between something that has a little bit of salt or a lot of it. And so we've taken two different things, two types of matters. We took salt, we took water, and we mixed them together to make a mixture. So what I'm going to do is highlight both of these categories separately. So let's talk about the types of pure substances. The first one is these substances can be elements. These are things that cannot be broken down into simpler substances. Now, a perfect example of this is the periodic table of elements. That's why it's called that. All of the things there on that periodic table um, cannot be broken down any further. So I'm going to kind of skip to the end of the notes here where there is a periodic table. So all of these substances, like if you were to have a sample of gold, you could cut that sample in gold in half. It's still gold, and so on and so forth. And you can keep on cutting it in half until you get down to literally one atom of gold, and you can't divide that gold anymore. And so that's what we refer to as an element. And I'll go more into that in a little bit. And then the other type of pure substance are compounds. Compounds are comprised of two or more elements. So, for example, I'll use water again. Water is made up of hydrogen and oxygen. Both of those substances are on the periodic table, oxygen and hydrogen. So when the compound is made, we combine two or more elements of that. And these compounds can be broken down by chemical means, or what we call chemical changes, to yield either elements, other compounds, or both. Like, for example, again, using water. I can take water and add electricity to it, and it breaks down into hydrogen and oxygen. Now, don't worry about, what all these numbers or anything mean. I'm just kind of showing you that water is a compound, and we can break that down into hydrogen and oxygen. We cannot break down hydrogen and oxygen any further. So we're starting with the compound here, and we're going down to elements that can't be broken down. Now, just to kind of go back to this, if you are following along in your textbook, there's a really cool video. I don't think I can show it for copyright reasons, like on a recorded lecture, but there is a really cool video that shows um, this is another very similar example where they take a compound called mercury oxide and break it down into mercury metal and oxygen gas. And they basically prove to you that they isolated the oxygen gas. So you can find that right in your textbook in this section about pure substances. So I highly recommend taking a look at that. It's only like a minute long, but you'll want to, kind of that'll help you in determining the differences between elements and compounds. Now, with mixtures, there are two types of mixtures. First of all, there are heterogeneous mixtures, and with these, the composition varies from point to point. Now, I have an example of Italian dressing there. And it's not a great picture, but if you like Italian dressing, you know that like when you go, you find it in the store, you look at it, it's like separated all out. The solution is not uniform throughout the whole thing. The mixture is not uniform. You have bits and chunks of stuff on the bottom. You have the oil separating out from the water. And if you were to take a random sample and analyze it, the composition that you would get from each result would look different. Also think of this on another macro scale like chicken soup. So you have chicken noodle soup, you got noodles, you got carrots in it, you got chicken, maybe celery, maybe some other things in there. And if you were to take one spoonful of that and eat it, and then take the second one. The second one probably doesn't have the same exact composition as as the first bite, and so on and so forth. And so that's an example of a heterogeneous mixture. Now, the other type of mixture is a homogeneous mixture, or also known as a solution. That's an important term. We're going to spend a lot of time talking about solutions eventually. And homogeneous mixtures have a uniform composition. That means if you have a solution, like let's say a solution of salt water, you take some salt, you dissolve it in water, you stir it up really well. You can't see the salt anymore. It's dissolved in the water. But if you were to take a small sample of it and analyze it, it would have the exact same amount of salt in it as the next sample that you were, excuse me, as the next sample that you were analyzing. And so I have kind of an example here of like Gatorade. If you were to take a sample, open up a bottle of Gatorade and take a sample of it, it would have the same exact composition, electrolytes and sugar and all that other stuff as a second sample that you would take from it, and the third and the fourth. And in fact, like you can almost do this yourself by taking a sip of Gatorade and then taking a second one, and it would taste exactly the same. And then a third and a fourth and so on. So that's what makes up a solution. So to kind of summarize this, and this is a great flow chart. If you're trying to decide, if you're looking at some matter, how do I know whether it's a mixture or a pure substance? And then once I decide that, how do I know, like if it's a pure substance, how do I know if it's an element or a compound? Or if it's a mixture, how do I know if it's heterogeneous or homogeneous? So that will pretty much conclude this lecture. On our next one, I'm going to wrap up the chapter, or at least this portion of chapter 1, and I will see you then.